These amoeba-shaped rock formations are meant to help with storm surge, erosion, and possibly oystering and fishing.
I mean, this reef is almost buried on this end, and we put it in and it looked like that. So we've had so much sediment accrete here. That's great. I mean, that means they're doing their job.
On September 26, 2024, Hurricane Helene made landfall near Perry, Florida. There was still significant storm surge here, over 60 miles away. It provided a test for this system.
So obviously during the storm event, the surge came up about 6 or 7 feet, and then as the storm surge retreated, that's when the system really kind of just turned into a big catcher's mitt and just held on to all that sediment that was trying to be pulled out into the bay.
Florida is vulnerable to rising seas and an increase in strong storms. How can a living shoreline like this one protect our coasts?
With my cowboy boots on. I was in the office this morning, so I had to look presentable.
The concept of living shorelines or green infrastructure, that's been around for a while now.
Much of Florida's forgotten coast is protected by extensive marsh or oyster reef ecosystems. But there are many places where roads or structures have no buffer from waves or wind. Using computer models, the Apalachee Regional Planning Council chose this site as the most suitable for restoration in Franklin County.
This project is intended to cut down on the day-to-day, the chronic erosion. It's not going to stop a Category 3 storm. The grass roots and the low-profile marsh are able to capture sediment. As water's rushing out, it stabilizes those loose sediments.
A living shoreline mimics coastal ecosystems, which slow wave action by causing friction. I learned about this a few years ago at the University of Miami's Sustain Lab.
Traditional construction of things like seawalls. So a seawall doesn't take any energy out, it bounces energy off of it.
But sometimes this also worsens up the conditions in nearby areas.
The key thing for waves is they go into things like salt marshes, oyster reefs, seagrasses, mangroves. They disrupt the motion of the water.
If we can actually dissipate the energy by breaking the waves, so turbulence, and you do it on the right locations, when they arrive at the shoreline, you'll have less impact.
The living shoreline concept really got two main components, especially for our design. We have the marsh and the reefs. As the waves come crashing into the shore here, they hit the reefs first, get slowed down, and then they hit the marsh. And the marsh is what pulls the last bits of energy out and settles down the sediment.
Waves coming in from the bay will first hit the reef balls. The holes in the reef balls slow wave action, much like Sustain Lab's Sea Hive.
The size of some of these guys in here is insane.
Like the Sea Hive, the hard surface of the reef balls provides a place for oysters to settle and build new reefs.
Yeah, look at these guys right there.
So do the rocks.
You can kind of see on some of these smaller pieces, nestled in on the larger ones, the oysters have started to cement the reef together. And as the oysters get larger, the amount of energy that they can pull out of the waves coming in increases over time. The bay is still under a moratorium. You can't harvest the natural oyster reefs. But we're not spat limited in this system. So that means when we put structure out like these reefs, over time they will be naturally seeded.
Spat are larval oysters. As these reefs build over time, they can provide additional spat for a recovering Apalachicola Bay fishery. The reefs also provide habitat for numerous other animals.
The birds have been all over these guys, so.
Like salt marshes and oyster reefs, seagrass beds are also a nursery for marine species. One of the biggest challenges here was designing their system around existing seagrass beds.
So we kind of had to adapt our reef design to mirror the shape of the seagrass beds. That's what's kind of leading some of the locals like to call it amoeba-like shapes. So that's what led to me and my team at WSP to going out and actually designing these reefs all by hand.
In its early stages, the system seems to be succeeding in gathering sediment and providing habitat. The true test of the system will come over time as it changes shape and expands.
These nearshore systems are extremely dynamic. The marsh will change over time. The seagrass obviously changes extremely rapidly. It is all part of the plan.
This is phase 1 of 3 currently permitted for this section of 98. Separate from this project, but within ARPC's scope, we are pursuing other locations along Franklin County.
But this was really meant to be the demonstration phase to show everybody in the area this is what we want to build, not the drawings, because I found that very much it's seeing is believing for this sort of thing.
For WFSU, I'm Rob Diaz de Villegas.